All, welcome back. Today we are going to solve the longest palindrome substring problem. What if I told you that every palindrome has a center? If we simply expand from each possible center, you can find the longest palindrome substring very efficiently without even checking every substring. In this video, I'm going to explain and solve Leetcode problem number 5 step by step, understand the intuition, and code the solution in Python as well as in C. So the problem is this. Given a string S, return the longest palindrome substring in S. For example, input S is equal to BABAD. The longest possible palindrome substring could be BAB or ABA. Both are valid answers. For input string S is equal to CBBD, the output is going to be BB, which is the longest palindrome substring. Rather than using a brute force method which takes a time complexity of order of n cube, I am going to solve it in a different logic in a time complexity of order of n squared and a space complexity of just extra one space, order of 1. Let's get into the problem. Step 1 is to understand the problem. We are given a string S, as we have already seen. We need to find the longest substring, longest contiguous substring, which is a palindrome. You all know what is a palindrome. Examples, madam, level, race car. So a substring, again, it's nothing but characters must be next to each other. Contiguous substring. Fine. So the aim is to find the longest contiguous substring, and that should be a palindrome. Step 2 is, I'm just going to give an example walkthrough with this example. I'm taking the same string S, which is BA, BAD. What could be possible palindrome substrings? B, A, D, BAB, ABA, among which I am going to find the longest substring. The longest palindrome substring is BAB or ABA. Both are valid answers. Right. Step 3, you have to observe. Key observation is very important. So we are going to formulate the problem and solve the problem in such a way that we assume every palindrome has a center. ABA, the center is B. RACE, CAR, the center is E. BB, the center is in between two B's. So this is my assumption, and that is true. So for each position here, we can expand outward and check whether the characters match. I mean to say, for example, ABA, from the center B, I can expand outwards. So the left is A and the right is A. I will check the left and right and see whether they are equal. If they are equal, it is a substring palindrome. That's my logic. Step 4, again, we are talking about centers. There could be two types of centers. I mean to say, the length of the palindrome can be odd or the length of the palindrome can be even. If it is an odd length palindrome, the center will be one character. So ABA, the center is B. Even length palindrome, the center will be in between two characters. So you need to check both. Important point to note here. Step 5 is to expand around the center. For every index I, expand from I, I for odd palindromes, expand from I, plus 1 for even palindromes, and you are going to keep the longest result. This is the core part of the logic. So what could be my algorithm? This is my algorithm. For each index I, check palindrome centered at I. Check palindrome centered between I and I plus 1. Update the longest palindrome. Return the same. Fine? Right. So this is my logic. From this logic, I am going to solve my problem. And this will take only order of n squared and a space complexity of order of 1. plus that excluding that return of the substring. That's it. If you solve it in the traditional approach, it will take order of n cube. So this is quite efficient when compared to the conventional method. Right. I'm taking the same example. My string S is BABAD. The index position of B is 0, A is 1, B is 2, A is 3 and D is 4. I is equal to 0. Done. Odd center. Find this 0, 0. What is a palindrome? I get B as a palindrome. Even center 0, 1. I cannot move left. Left is -1. So I cannot move there. So even center 0, 1, BA. BA is not a palindrome. So far the longest palindrome is B. I equal to 1. Odd center 1, 1. So expand. From A you expand BAB. BAB is a palindrome. Even center 1, 2. 1, 2 AB, which is not a palindrome. So longest palindrome so far is now BAB. I is equal to 2. Odd center 2, 2. Right? Expand. From B expand. A, BA, which is again a palindrome. Even center 2, 3. BA. BA is not a palindrome. Longest remains BAB since ABA is also the same length as BAB. Both are correct answers but. I is equal to 3. Odd center 3, 3. Expand BAD, not a palindrome. Even center 3, 4. AD, not a palindrome. I equal to 4. Only D is left because see you cannot move right. It is out of bound 5. So final answer will be BAB. ABA is also a valid answer. Right? Okay. So I have written a small Python function as well as a C code to actually implement this part. So the key logic is only to find the center. So this is what is very, very important. The key takeaway is that I treat every index as a center of the palindrome. For each center, I expand outwards for both odd and even length palindromes. The function is going to return the start index and the length of the palindrome and compare and keep track of the longest palindrome found so far. Fine? Right. So this is my Python code. The actual algorithm is based on the idea that every palindrome has a center. You can look at the expand function. This starts from 2 indices and expands outside while the characters are equal, returning the starting index and the length of the palindrome found. So also look for each index I in the string. You're going to check 2 centers, I, as well as I, I plus 1, based upon whether it is odd or even length. And choose the longer of the 2 palindromes and compare it with the longest palindrome found so far. If it is longer, you are going to update the starting index and the maximum length. After checking all possible centers, return the substring using the recorded starting index and the length. That's it. And this is your C version. In the C implementation, the same logic is used. Expand function. It is taking the string length, 2 indices left, right, and a pointer to store the starting index of the palindrome. And the function again expands outwards while both indices are within the bounds and the characters are those positions are equal. That's being checked. When this expansion stops, it actually stores the starting index as left plus 1 and it returns the length of the palindrome as you can see, right minus left minus 1. So the main logic is you have 2 variables, start and max length, which keeps track of the starting position and the length of the longest palindrome found so far. Again, you can see, for each index I, the algorithm calls expand twice. One for I, and the other for I, I plus 1, as we have already discussed. It selects the longer of the 2 results, and if the length is greater than max length, it updates starts and max length. After all the centers are checked, the longest palindrome substring is the portion of the string starting at the start and having the maximum length. So this is what is the C implementation. Any doubts, post it in the comment section. I'll be happy to explain. You have a simplified version of the same problem, the same solution. Please do post it. Happy learning. Thank you all.